Assalamu alaikum. This is a demonstration of my CS211 Discrete Structures semester project. And this demonstration is essentially divided into 5 parts. Section 1, my name is Zohaib Adnan. My roll number is 19I0741. And I've been working with Moiz Sajid, whose roll number is 19I0692. In section 2, I'll go over the procedure to get Prolog up and running, and I'll run an example program. So the Prolog environment that we're using is SWI Prolog, and installing it is fairly simple. Just go on their website and you download the latest stable release. And once you've followed all the steps in their installer, it should show up in your installed applications. Now, if you open this, it opens the main terminal, and this is where you basically do all your work and you ask Prolog questions. All right, so I have prepared an example file, example.pl, because our Prolog files use the .pl extension. And in this file, we basically have 3 facts and then 1 rule. So fact 1 is John likes Jane. Fact 2 is Jane likes John. Fact 3 is Jack likes Jane. And then our rule is defined as person X and person Y are friends if and only if person X likes person Y and person Y likes person X. So now I'm going to demonstrate how you would ask Prolog questions. So I'm going to open the file by consulting it. And we'll go to desktop and look for example.pl. And now I'm going to ask it. Let's ask Prolog for a person that John likes. So we can ask it, likes John, and then X, and then we add a full stop. And Prolog returns Jane, which again, based on the data we have, is true. Now, if I were to ask Prolog, does John like Jane? It returns true, which again, based on the data we have, is true. Now, if I asked Prolog whether or not Jane likes Jack, you get false because this fact has not been included in the data we have. And again, if I ask Prolog, are John and Jane friends, we would get true. And this is true because John likes Jane and Jane likes John back, which fulfills the requirements of our rule. If I were to ask Prolog whether or not Jack and Jane are friends, you would get false. Because even though Jack likes Jane, Jane does not like Jack back. And so our rule here is not fulfilled. So this is a very simple example. And this completes section 2 of this demonstration. Now for section 3, I'll basically explain the procedure of preparing my knowledge base. So I have a file here called knowledgebase.pl. And this is essentially the entire collection of facts that we're using for our project. And the procedure here was fairly simple. We basically just used the Excel file that was provided to us. And we kind of went over the requirements that were given here. So these are all the predicates that we're supposed to use. And we basically just use these and along with the concatenate function. So there is a concatenate function in Excel, and we use that to kind of make our facts here. Now, a couple of important details here. I did use quotation marks because Prolog does not work nicely with special characters or spaces. And I mean, one way to remove this error is to obviously remove these spaces and to remove or replace any special characters. But adding double quotations or single quotations works fine. So these are all the different predicate types we have. So the first predicate type is student roll number name. And this basically has the roll numbers and the names of all registered students. And if we scroll down, the next predicate type is instructor, which has the email ID of the instructor and the instructor's name. The next predicate type is course, CID title, where we have the course ID and the title of the course. We have course section, which has the course ID and the sections that are being taught for those courses. So, for example, discrete structures has multiple sections, and data structures has multiple sections, and they're all listed here. Our next predicate type is section, which has the sections of all registered students based on their roll numbers. Our next predicate is teaches. So this basically has the teachers' emails along with the sections they teach. And then we have capacity. So each room, every room's ID and the number of students it can accommodate. And finally, we have exam times. And these are based on the mock date sheet that was provided to us. And again, this procedure was fairly simple. I just had to make sure to follow this format. So, for example, in the case of exam time, I had to make sure that the first element here represents the date, the second element represents the starting time, and so on. Fairly simple. I basically just used the concatenate function and I copy pasted all of this. And there were some predicates where I had to manually enter details, but it was fairly simple. Now for the next section, I will be going over the execution of my queries, which are odd queries. So I basically dealt with the odd queries, and Moiz will be going over the even queries in the later section of the video. All right, so if I open rules.pl, this is basically where we defined all our rules. And if you notice, we did include the knowledge.base.pl file, which means that all that data is available in this file for us to use. So if we look at our queries, the first query is whether the given student name has 2 exams in one day. So what we have here is double exam name. And the first step here is to find our student's SID or their roll number. And we've used student A/name. So the student's roll number is basically represented by A. And then the next step is to find their section. And so we use the section predicate type. And we've used the same roll number here, and we're trying to find our student's section. And then the next step is to basically find 2 courses, which are represented by C and D, that have the same section as our students. So B here represents our students section. And then we're trying to find 2 courses, and C and D represent course IDs here. We're trying to find 2 courses that have the same section as our student. And then we're trying to check whether or not these 2 courses have exams on the same day. So if you notice here, this is the exam time predicate type. And if we go back to our knowledge-base.pl file, we'll notice that the format for this predicate type is date, start time, end time, course ID, and room ID. Now, if you notice here, these 2 elements are the same, E and E, which represent the day. Because once again, we're trying to find out whether or not 2 courses have exams on the same day. And we're not concerned with anything else. We're not concerned about the starting time or the ending time or the rooms for that matter. We're only concerned about these 2 courses, and we're trying to figure out whether or not they have exams on the same day. All right, so if I refer back to our mock timetable, it's fairly obvious to see that every student in our knowledge database has 2 exams on day 1, because again, every student, every section has their discrete structures and their data structures exams on day 1. So if I were to open SWI Prolog again, and I'm going to consult our file, which is rules.pl. All right, so now I'm going to ask it. I can use myself here as an example. Do I have a double exam? Oops. Syntax is very important here. And this reply is true because, again, I do have both exams. I have a discrete exam. I have an exam for discrete structures and data structures on the same day. Now, I can't actually demonstrate a false value for this because, like I said, every student in our knowledge database has 2 exams. But if, for example, I ask Prolog whether or not student XYZ has 2 exams, it replies false because XYZ is not defined in our knowledge database. And this is why it returns false, because it doesn't have enough information to figure out whether or not XYZ has 2 exams. If XYZ was defined in our knowledge database, and if XYZ did have 2 exams, then this would return true. So for the next rule, the next query, query 3, whether 2 courses with the given course name have the exam at the same time. So I'm going to go back to rules.pl, and here we have rule 3, which is exam collision, course name 1, course name 2. So basically we're sending in 2 different course names, and so obviously the first step is to obtain the course IDs for both courses. And so we're using the course predicate type, and A and B represent the course IDs for course 1 and course 2 respectively. And now we're trying to figure out, are the exams for both these course IDs scheduled on the same day, which is represented by C, with the same starting time, which is represented by E and D. So what we're trying to figure out here is we're not concerned with the rooms. The rooms can be different. We just want the days to be the same, and the starting and the ending times to be the same. And this rule can be accomplished even if we did not factor in the ending times. So even if I change these 2 variables, let's say if I change the ending times, this will still work because, again, we're trying to figure out which 2 courses have the same exam on the same day and have the same starting time. All right, so if we go back to our mock exam timetable, we can see that discrete structures and data structures have their exams on the same day and at the same time. So if I were to ask Prolog, and data structures, it returns true, which is, again, what we were expecting. Now, let's look for an exam that does not have a collision. What if we try, let's try marketing management and weight being the same day. So we can try, let's try Cole and fundamentals of management. Let's try these 2 courses because although they are scheduled on the same day, they have different times. So Prolog should return false. Let me just look at the names for both courses, because there is a certain syntax that we have to follow. All right, so fundamentals of management, that's here. And then do we have Colab? We do not have Colab. Oh, we do, okay. All right, here we go. This is Cole, okay. So let's try double exam. And then course 1 is fundamentals of management. And second course is computer Again, the syntax here is very important. Ooh, and we do have an error. What exactly is the error here? Oh, I was using the wrong query. So we're using exam collision and not double exam. Excuse me for that. This isn't the best example to demonstrate this query since these are very long names, and this is false. So again, this proves that this prologue is working correctly because again, these two exams are not colliding. They're on the same day, but they're scheduled for different times. So it doesn't really, so prologue returns false. All right, so for query number 5, whether the exams in the given room can be switched with another room having the same capacity. So if we go back to our rules, is switch possible? This is the rule that we're looking at, and a switch is possible if both rooms room 1 and room 2 have the same capacity, and if room 2 is free. So that's basically how I've programmed this rule. So if room 1 and room 2 both have the same capacity, and room 2 is free, that's kind of why I have a not here. If room 2 is free, there's no exam there, only then will this return true. So if we were to try and switch, let's say, C301 to C302 on day 1 at 9 a.m., we should get false. So is switch possible? And we'll use room 1. So let's use C301, C302. And we're interested in days 1 at 9 a.m. False. So the switch here is not possible because discrete structures, C302 is being used at that time. Now, if I were to use, let's say, so let's try moving fundamentals of management on day 5 from C301 to C310. C310 is empty, so this should return true. So if we use we're switching C301 to C310 on day 5 at 9 a.m. True. And again, that's expected because C310 is empty on the 5th at 9 a.m. So prologue returns true. All right, let's go back to our rules. So the next query is whether two students' names have a common section of the given course name. So this is query number 7. And if I go back to my rules.pl file. All right, so rule 7, have common section. So basically this returns true if student 1 and student 2 are registered in the same section for a certain course. So obviously the first step here is to find both students' roll numbers or student IDs, which are represented by A and B. And then we're looking for the course ID for the given course name. So we use the course predicate type. And then finally, we're comparing all 3 sections. So basically, what we're trying to figure out is, are these 2 students, is their section, are they in the same section for that course? And so that's kind of why we have D variable here. D is same for all 3 predicate types. So to demonstrate this query, I'm going to use myself as an example. So have common section. And then I'll use a friend of mine who's also in the same section as me. And let's test linear algebra. And this is true because Ali is in the same section as me. So if I wanted to prove this false, I would go to my knowledge base and let's look for someone who's not in section B. Let's look for someone from section A, perhaps. Yeah, so let's go with 18I0641. And that would be Moiz Ali. All right, so let's compare. I'm going to test myself with Moiz. And let's test linear algebra again. And false, which is again expected because Moiz is in section A. All right, so for my last query, query 9, whether a given instructor name teaches 2 sections of the same course. So query 9 is teaches 2 sections, and we're basically sending an instructor's name. So obviously the first step here is to find the instructor's email, and that's what we're doing here. And then we're trying to find 2 sections that this instructor teaches. And then the next step is to figure out whether those sections are the same course. So obviously this query, so 2 common sections of a given, 2 sections of the same course. So the course has to be the same, which is why here D is, we're not changing D because obviously we want the course to not change. All right, so if I refer back to my Excel file and we look at data structures, we can see that Ms. Saba teaches both sections C and D of the same course. So if we were to go back to SWI Prolog and type in teaches 2 sections, and we use Ms. Saba here, this is true, which is again expected because Ms. Saba does teach 2 sections. But if we were to use Sir Adnan, for example, we should get false. False. And again, this is expected because Sir Adnan only teaches section A for data structures. But that's about it. That's my part done. I've gone over all the odd queries, and I'll now be handing over to Moiz, and he'll cover the even queries. Thank you for watching.
Assalamu alaikum. My name is Moiz, and I'll be handling the even parts, even rules of our knowledge base for the Discrete project. So I'm going to walk you through the process. I'm going to explain each rule and then run it to verify the true and false statement for each rule. So let's go ahead and start Prolog. I am going to open my files for the rules and the knowledge base. So you can see this is the knowledge base I made, and these are the rules defined for it. I have the even rules 2, 4, 6, 8, and 10. Let me go ahead and consult these files. It's consulted. And the rules file. These are just the warnings of static variables. First off, I'm going to explain this rule. This rule tells whether the given instructor name is teaching any of the sections of the given course name. These are examples I'll be using. I've just saved them here. First off, we're getting the name of the instructor and the course name. We've put it in the instructor defined in the knowledge base. Let me just show you. This is the instructor defined in the knowledge base, which takes a name and gives the email ID of that name. So we give the name of the instructor and get the email ID in A. A stores the email ID. And then we use the course fact and we give the course name and it gives us the course code. putting the course code in the course section fact, we get the course C stores the selections this course is taught in, and then we put C in teachers fact to get a does the teacher with email ID A teach the section C. Basically, C stores the courses that this course with ID B is taught in. So let me just run it. Let's say Sir Hassan Mustafa teaches data structures. So let me just and see, it gives true because Sir does teach data structures according to the given knowledge base that we have. Now, if I write, does Sir Hassan Mustafa teach, I don't know, fundamentals of data science, which Sir does not, according to our knowledge base, it will return false. You see, it gives false. We go on to the next one. We have room collision. This rule tells whether two courses with a given course name have the exam at the same time in the same room. Now, if we look at our provided Excel Access sheet, which is right here, we can see that none of the exams have the same room for the exams. None of the courses have the same room for the exams at the same day. So it should return false if I input discrete structures and data structures because the room numbers are same for the same day, just 1. Let me just input data structures. And it should return false because they're in different rooms. Oh, there's a syntax error right there. This does not have a space in it. Apologies. See, it returns false. Now, if I put data structures here, it will return true because you see we have data structures and they collide with each other in the same room on the same day. The code for this is that we have course names coming in and we put it in this course fact. A stores the ID of the course having the name course name 1 and B stores the ID of the course with having the name course name 2. Then this is unnecessary. I just did it. It X and Y store the sections of courses 1 and 2 having the ID A and B. The exam time fact stores the day in C, the start time in D, the end time in E, the course ID in A, and the room ID in F. These are different, but we're checking to see whether the courses A and B are different. These courses have different codes, but we're going to check whether the day is same, the start time is same, the end time is same, and the classrooms are same. And if they're same, it returns true. If they're not, it returns false. Moving on to rule number 6, it tells us whether the given room is being used as an exam room in the date sheet on the given day. So we're just going to input a room and we're going to see if it's being used as an exam room. For instance, let's just put C301 in it. I'm just going to call it check room. Start time is 9 a.m. I believe. And it's going to return true because we have an exam at that day in that room. Now, if I put 2 here, meaning do we have an exam on the second day in room C301? Well, according to the mock date sheet, we don't. Let's check that fact real quick. Returns false. What it does is it basically uses the exam time fact in the knowledge base and checks whether the room with the given ID is being used as an exam room on the given day, where B is any end time and C is any course. Just checks in the whole knowledge base. Moving on to rule number 8, belong to duplicate. We're going to check whether a given roll number belongs to two roll numbers. We're given name, sorry, belongs to two roll numbers. First, I've given a name here, and the student fact returns the roll number in A and in B. If the roll number is same, we're going to check here. A is not, this means A is not equal to B. It returns true if the name has duplicate roll numbers, otherwise false. Let's check the fact real quick. I'm just going to put in my name. Now, I don't have a duplicate in the knowledge base, so it should return false. See, let's just update the knowledge base. These are the students, and this is my roll number. If I put it at the end, that means I'll have a duplicate. Let's just change this roll number to something like 999 and another 9. I'm just going to save the knowledge base. Then I'm going to run it again. Now it should return true. Oh, let me consult it first. It should return true right now. See, it gives true because I have a duplicate right now. Moving on to the final rule, rule 10, whether a given instructor name teaches two different courses. I've given the instructor name, and this fact right here gives the stores the instructor email in A. Teaches, B stores the section the teacher teaches in. I've done the same here, given the same email address of the same instructor, and if there are multiple sections, it's going to be stored in B and X. Assume there are two sections, and one is stored in B and one is stored in X. C here gives the course ID for the section the teacher teaches in. For instance, the first section was in B. The course ID for that section is stored in C, and for the second section, the separate course ID is stored in Y. I'm going to check these in the course, where D gives the course names the instructor teaches, and Z also gives the course names the instructor teaches. But I have given the course IDs here, C and Y. These are two different IDs, and these are two different course names. If D is not equal to Z, the condition returns true when both course names are different, meaning the instructor teaches two different courses. Otherwise, it will return false, meaning the teacher teaches a single course, meaning D and Z, the course names are same. Let's just run it. Teaches two courses. We have Hassan Mustafa in our knowledge base who teaches two courses, so it will return true. See, now if I try Sir Hassan Raza, does not teach two courses, will return false. See, and that is pretty much it. Thank you for watching. Allah Hafiz.